Hello guys, welcome back to my channel. Today we're going to be looking at some CXC Mathematics Past Paper 2. However, we're going to be focusing specifically on some algebra questions and we're going from 2010 to 2015. In our next video, we will go from 2016 to 2022. Now, without further ado, we'll get right into the questions, and this is in May 2010. Alright, it says, given that A is equal to -1, B is equal to 2, and C is equal to -3, find the value of A plus B plus C. Well, this one is straightforward, right? We have A plus B plus C. Now, this question is a matter of what we call substitution, which simply means we're going to be putting A as the value that it is, B as the value that it is, and C as the value that it is. So we're going to have -1 plus B, which is plus 2, plus C, which is plus -3. Now we can do all of this one time. We can put this even in our calculator. Alright, but -1 plus 2 is 1, and 1 plus -3 would give me -2, and that's the end of my answer. And this is part 1. Part 2 says b squared minus c squared. Alright, so we have b squared minus c squared. And the concept of square means that you multiply something by itself. So I'm going to have 2 squared, use up your brackets, minus, in bracket, -3 squared. Very important that we use the brackets. Now, 2 times 2 is 4. That's what 2 squared means. -3 times -3 is +9, as negative times negative is a positive. So it's 4 minus 9. Now 4 minus 9 would give me a -5. Good? Now of course you could have put it in your calculator from up here, but I'm simply working this out so you understand it also in the case that it was a paper 1 question. Alright? So that's why I'll be doing a lot of the working that I'm doing. Now this is moving on to 2b. It says write the following phrases as algebraic expression. Alright, so 7 times the sum of x and y. Now listen carefully to the question. 7 times the sum of x and y, which means you have to find the sum of x and y before you can multiply it by 7. So let me just do it right here. So the sum of x and y means that you're going to add them, x plus y. Now this becomes an algebraic expression right here. And so when I say 7 times the sum, I need to have 7 times all of it. What represents all of it is when I put a bracket around it, and then the 7 goes right in front. Now because I have the bracket already, the times, which means to multiply, I don't have to put it there because it is indicated by the bracket, as in 7 times all of this. Alright, so it says part 2, the product of 2 consecutive numbers when the smaller number is y. Good. Now, 2 consecutive numbers means that the numbers come directly after each other. For example, look at my left corner here. 4 and 5 are consecutive numbers. What's the difference between 4 and 5? 5 is 1 more than 4, and that is how consecutive numbers work. So if one number is y, which is the smaller number, the number after y, you're going to have to add 1, which gives you y plus 1. Now, product suggests that you multiply, right? So what it means is that I'm going to have the smaller number, which is y, multiplied by the larger number, which is y plus 1. And you do understand why we need a bracket, because this expression here is going to be multiplied by all of y. So it's y times y plus 1. All right, good so far. All right, let's pick it up. Now we're moving on to question C. Now question C, let me just go down a little so we can actually see where I'm at. Question C says, solve the following pair of simultaneous equations. Now let me just go back over here and replicate them. I have 2x plus y equal 7. And I have x minus 2y is equal to 1. Now, of course, when it comes on to simultaneous equation, you know you're going to work out the technique that you're going to approach the question with. That technique that you're going to approach a question with is simply up to you. All right? You use the technique that you want to use. Now, of course, since the questions are lined up perfectly and nicely for me, then of course one of the better techniques to use here would be the method of elimination. All right, so let me go ahead and label the equations in a different color. This is equation 1 and this is equation 2. Now, let us say we want to eliminate x. So I could use the coefficient of the x in the second equation to multiply the equation at the top, and the coefficient of x in the first equation to multiply the one down here. That makes it pretty easy and straightforward. So I would multiply equation 1 by 1, because that's the coefficient of the x in equation 2, and equation 2 by 2. Now the aim of this is so that the coefficients of the x become the same. Once they're the same, then they can be eliminated by simply subtracting both equations. But as you know, if I'm going to multiply equation 1 by 1, it's just going to remain the same. So I have 2x plus y equal to 7. But I multiply everything in equation 2 by 2. So I'm going to have 2x, 2 times negative 2 is going to give me a minus 4y, and 2 times 1 is going to give me a 2. Alright, now this is the aim. Notice the coefficients of the x are the same. So when I subtract them, I'm going to get 0. That's gone. Now, y, which is positive 1y, minus, watch the signs now, negative 4y. What I really have there is y minus minus 4y. And these two consecutive minus signs give me a plus. So I'm going to have y plus 4y. Now that is going to give me 5y. And of course, 7 minus 2 is going to give you 5. Now we divide both sides by 5. So y becomes 1. Alright, almost done. Now once you have the value for y, you use any equation of your choice to find the value for x. So I could use equation 2. So I could say sub y equal 1 in equation 2. So what I'm going to have is that x minus y is 1, so I'm going to have 2 times 1 is equal to 1. Alright, now 2 times 1 is 2, so x minus 2 equal to 1. Which means all I have to do is bring over that 2, add it to 1, so x is equal to 1 plus 2, x is equal to 3. So at this point, let me come right where the question is the right answer. Therefore, x is equal to 3, as x comes first, when plotting graphs, based on the graphical aspect of it, and y is equal to 1. And that would be the end of my question right there. Right, so let's clean it up. So we have the space, do question D. Now question D, in the meantime, let's read it. It says factorize completely. Alright, so we're going to go into factorizing. Remember, factorizing is writing something as a product of factors. That's what it means. Now I could probably do part 1 right here. Now if you look, normally when you're trying to factorize, we're trying to look for something that is common. If you look at question 1, you notice that there's nothing common, which tells you that the approach must be slightly different. Now, of course, 1 difference of 2 squares, and as you can see, all terms here are square terms. Now, simply put, we know that whenever we have a difference of 2 squares, as in a squared minus b squared, when we factorize this, we get a minus b times a plus b. So we have to try to remember now, how do we get a and b in this, and how do we identify the difference of 2 squares? Normally, when nothing is continued out with an expression that looks squared like this, normally it indicates that it's the difference of 2 squares. So in this case, I'm probably going to have to rewrite this. So I could rewrite it as 2y all squared. Laws of indices. If you have a product that is squared, you can simply just take out the square, put it outside, right? Because remember that 4 is really 2 squared. So I can write it as 2y all squared. And this is minus z squared, which tells me that a is 2y and b is z. So you deal with them likewise. So you're going to have a, which is 2y, minus b, which is z, and then again a, which is 2y, plus b, which in this case is z. So a lot of things that we do in maths, we can do it by pattern. All right, case number 2. I'm going to put it right here. Classical case, normally when you see 4 terms, so you have 2ax minus 2ay minus bx plus by. Normally, whenever you have 4 terms, of course you realize that there's nothing common among all 4 terms. So this normally indicates a kind of grouping and factorizing scenario. So you pair them off. All right. Now, in the first case, we look for what is common. Starting with the numbers. 2 is common, a is common. 2a goes on the outside. Now 2a multiplies everything on the inside. Alright, so if I take out 2a from the first term, I'm going to be left with x. 2a from the second term, I'm going to be left with a minus sign, and I'm going to be left with a y. I didn't touch that. Now, of course, what's in the first bracket should also be the same thing in the second bracket. So I need to have the minus sign right here, which means in order for me to have the minus sign here, I realize that b is common. I'm going to have to factor out a minus b. Right? Now, factoring out a minus b would mean that the signs would automatically change. So I'll be left with x right here, and the plus sign becomes a negative sign because when I re-expand the bracket, I should get back the plus sign that is there. And of course, the y is left on that side. This is perfect because my 2 brackets now having exactly the same thing, including the bracket. The bracket is common, so I'm going to take out the bracket with whatever it is in there, x minus y. And then if I take out the x minus y with a bracket from both sides, just block them out mentally, all you're left with is 2a on the left and a minus b on the right. So that is how we factorize that expression completely. All right, so we're done with question 2. Question 3, and you have to be able to recognize this one, very common, always a part of your exam, what is called the quadratic expression. So here we have 3x squared plus 10x minus 8, right? And we have to know how to recognize this. Looking at the expression itself, you have your square term, you have your non-square term, you have your constant. Good? Now the constant could have been 0 and it could have still been a quadratic expression. It's just that probably your approach would be a slightly different. Now, in this case, we have to introduce what is called the AC method, all right? Now, this is A, this is B, and this is C. Watch the signs as well. So it's 3 times negative 8, not 8, but negative 8 is negative 24. Now, remember what we want. We want 2 numbers. When you multiply them, you get negative 24. When you add them, you get a positive 10. You know, because the 10 is positive here, that tells me that the higher number has to be positive and the smaller number has to be negative. Because when you're going to add those numbers, you have to get a positive 10. But if you multiply them, you get negative 24. Now, here's an easier way to look at it. Let me not even say add them. Add or subtract. That makes it easier for me. Good? So what give me 24? All right. I know 2 times 12 give me 24. Now, of course, the smaller number has to be negative. So I can say, let 2 be negative. Now 12 minus 2 gives me 10. And negative 2 times 12 is negative 24. I found the answer. But what if you were thinking 4 times 6 first, for instance? And if you were to make 4 negative, 6 minus 4 is 2. You wouldn't get 10. If you use 3 and 8, 8 minus 3 would not give you 10. Alright, so you'll be left with 2 and 12. Of course, you can use 24 and 1, and that's way off. So what I do is that I'm going to use a negative 2 and a positive 12 to rewrite the middle term, which is b. In other words, the 3x squared comes back. Alright, now I'm going to have 12x, right, and 12x minus 2x. 12x minus 2x again is 10x, and 12 times negative 2 is negative 24. So that does work. And the c terms, which is minus 8, come back. Now what is beautiful about this? It becomes like the previous question, 4 terms. So it's about pairing off. Pair those off, pair these off. Alright, now what can I factor out? I have 3 and 12. I can take out a 3. I have x squared and I have x. I simply take out the lower one, which is x. Now if I take out 3, 3 into 3 is 1, so that's gone. You have x squared, you take out 1, so you have an x left right there. Same concept we apply. 3 into 12 is 4. The x that was there is gone, so that's out. On this side, I need this bracket to be the same. I have negative, well, the negative sign is common in this case. I can factor that out. What number can go into 2 and 8? That's 2. X is not common, so that goes back right where it is. Now, negative 2, if I take it out from here, I'm left with x alone. Negative 2 into negative 8 is going to give me a positive 4. So we have to know how to operate with negative signs. Now look at what is common now. The bracket and what is inside of the bracket is common. So you take out the bracket, which is x plus 4, including the content of the bracket. Now if you were to block out those two brackets now, block them out, what you'll be left with is 3x minus 2. And that's your final answer there. Alright, so that will be the end of question D. D as in dog. And we're moving down to 2011. Alright, here we go. Now 2011 starts off with, and of course, let me just go up a little so we can probably use the space at the top. Alright, here we're starting off with some algebraic expressions, algebraic fractions, and it says 2a, write as a single fraction in its lowest term. Alright, that's for 3 marks. So without further ado, we'll get into it. Now we think of this like how you think of a regular fraction. You have x minus 2 over 3 plus x plus 1 over 4. With a regular fraction, if you're adding regular fractions, the denominators are not the same. You proceed to find what is called the LCM, which is the lowest common multiple, or we can call it the LCD, 3 and 4. Your lowest common multiple would be 12, so you have to know your timetable. Now, 3 into 12 is 4. That 4 will multiply the numerator, so I'm going to be very careful. 4, I need a bracket, which also means multiply. 4 into 12 is 3. That 3 will multiply the numerator, which is x plus 1, once again. Because why do we use a bracket? It's going to multiply all of it. Now let's expand. So I'm going to have 4x, 4 times negative 2, negative 8, plus 3 times x, plus 3x, watch the signs, 3 times positive 1, plus 3, all over 12. We're good to go so far. Now, looking at like terms, you're going to have a positive 4x plus 3x is going to give you a 7x, but a negative 8 plus 3 is going to give you a negative 5 over 12. Can that go any further? No. Alright, unlike terms, so that's the end of your expression. Alright, let me see if I can get the next one up top right here so we don't run out of space. Draw a line right here, and let's get right into it. This is what we call binary operations. Question B. It says the binary operation asterisk is defined by a asterisk b equal a plus b all squared minus 2ab. What we want is 3 asterisk 4. Now, how do I think of this? I think of a as being 3 because they're in the same position, and b as being 4. So everywhere I see a, I'm going to be putting 3. Everywhere I see b, I'm going to be putting 4. Can't go wrong. So this becomes, in the bracket, I have a plus b. Remember, a is 3, so it's going to be 3. And b is 4, so 3 plus 4, all squared, minus 2ab. So 2 times a, which is 3, times b, which is 4. I'm good to go. So I have 3 plus 4, which is 7. So that's 7 squared, minus 2 times 3 is 6. 6 times 4 is 24. Now remember, calculator can do all this. I'm just doing this just in the case that if we were doing a multiple choice, we would have to do it manually. Now 7 squared is 49, ensure you know your timetable, minus 24, which of course is going to give me 25. Alright, pretty straightforward. Just know that you replace the things that are in the same position. Alright, we are back down to a factorization question again. And that's in question C1, factorize completely. Now we have two terms. And every time we factorize, we always try to find what is common. So notice in this case, I have x y cubed, right, plus x squared y. We're looking for what is common. What is common? X is common. We have x and x squared. All right. Of course, I can factor out the lower one. Simple technique to remember. X and x squared, you take out the lower one, which is x. Y cubed and y, the lower one, which is y. Now, if you take out an x from here, there's only one of them here. Or the power here was only one, so that's gone. You have y cubed. You take out that one, so you're going to have y squared left. In this case, if you take out an x, you have x left because it's x squared, which means x times x. You took out the y, so y is gone, so you don't have anything else left there, right? So it's y, open bracket, y squared plus x, and that's done, all right? In question 2, you have, all right, let me write question 2. I have 2mh minus 2nh minus 3mk plus 3nk. Now, what do I do? Remember now, it's 4 terms. All right, you can't go wrong. It's always about pairing them off. 4 terms, you pair them off. All right, what is common in the first 2? You have 2 common, your h common. You take those out, you're going to be left with what? M minus n, which means that you want the same thing in the next bracket. Now, of course, you have 3 over here, but you have a plus sign in between, and you can't get a minus sign if you don't factor out a negative. So it becomes 3, k is common, and of course now this becomes m minus n. Why minus? Because you factor out the negative sign. Now, what is common now? The bracket is common with the m minus n, so you take out the m minus n with the bracket. What you'll be left with is 2h minus 3k. Right, good, 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 good. Right, let's take it down to question D, as in dog. It says the table below shows corresponding values of the variables x and y, where y varies directly. All right, very good. Y varies directly. So let us use a symbolic representation for vary. Y varies directly as x. What it means, is that when y varies directly as x, it means that if y increase, x increase. So in order to get y, you can simply take x and multiply by something to get y, but it is consistent. We don't know what that value is that we multiply x by to get y. So we're going to call it k, or anything you want to call it. So when you write the equation now, it becomes y equal kx, because you're going to multiply x by something to get y. That is basically what the concept here is about. All right? In fact, you could actually just look at a part and you figure out what k is, because 212. How do I get 12 if I have 2? Simply multiply by 6. Now, y equal kx, but we need to show the working here. So, what do? We need to find k, and here's how we find k. K is what we multiply x by to get y. Now, you could put in the value for y, which is 12, put in the value for x, which is 2, and work it out. But of course, intuitively, you can just use a set of value. It's not complex workout. So, we know that k is equal to 6. All right, but if you don't trust the process, you can work it out manually. Of course, you don't need to do that in this case. But what if the values weren't so direct that I just look at it and know it's 6? I would say 12 equal k that I don't know times 2 that I know. So 12 equal 2k. Divide both sides by 2. K would be equal to 6. So y is equal to 6 times x. So when x equals 5, good. When x equals 5, y equal to 6 times 5. So 6 times 5 is 30. So it means that a is equal to 30. And that's done. In the second scenario, what they give you is the y value. Remember, the equation you're working with is y equals 6x. Look at the table, you notice that y is 48. What is x? So I'm going to have 48 equals 6x. So what do? I need x, so I simply get rid of the 6. It's multiplying, so I divide both sides by 6. Now 6 into 48 is going to give me 8. I'm done. So b, which represents my x value, is equal to 8. Alright? So that's how we have to work out something like that. Now, going down to 2012, what I want to do, May 2012, is that I can start it from the top, so I can get more space, right? So I'm going to start it from the top. Let me just simply take out the side right here. So I can start it from the top, and I'm going to go 2a, and this is part 1. 2a part 1. Once again, we have an x factorization question. So we have 2x cubed y plus 6x squared y squared. We want what is common. Once again, sort out the numbers. What number can go into 2 and 6? That's going to be 2. You have x cubed, you have x squared, you take out the lower one, which is x squared. You have y squared, you take out the lower one, which is y. Now what do you have left? 2 is gone. It was x cubed, you took out x squared, you have an x. It was y, you took out the y, that's gone. 2 into 6 is 3. You had x squared is gone. You have y squared, took out y, so you're left with y. Alright? Can't go wrong here. Part 2. You have 9x squared minus 4. 9x squared minus 4. Nothing is common, it's 2 terms, they're all square terms. 9 can be written as 3 squared. And you have x squared there already, so you can just go 3x all squared. 4 can be written as 2 squared, so minus 2 squared. This is the difference of 2 squares. So simply put, it's going to be 3x minus 2 and 3x plus 2. Alright? And the amount of this that we have done so far, by now we know the procedure. Alright, let me put part 3 right here. We have 4x squared plus 8xy minus xy minus 2y squared. Alright, good. Now, once again, it's 4 terms. You know what's that about? That is about pairing off. Pair off, pair off. Alright, in the first two, we can talk about 4 and we can talk about x. Alright, that's common. 4 is gone. We took out the x. We have one of the x's leave. 4 into 8 is 2. You took out x, so all you have is y there. The negative sign is common over here, so I can take out the negative. Y and y squared, that is what is common, so I took out the lower one, which is y. I didn't touch x, so the x is left. And of course, you took out the minus, so naturally you're going to have a plus. You took out one of these y's, so you have 2y. Perfect. The brackets having the same thing. So you take out the bracket that is common, which is x plus 2y. And of course, what is left outside is 4x minus y. And that is it. You're good to go. Alright. Working good so far. I'm going down to question 2b. So what I'm going to do is simply put 2b on this side here so that we have enough space to work. Alright. It says solve for x. So we have, and of course this is an algebraic fraction. What we have is 2x minus 3 over 3 plus 5 minus x over 2 is equal to 3. Now when it comes to solving equations, one of the things that people tend to normally not want to have is fractions, because fractions sometimes tend to make your life a bit challenging. So to ease your mind, we're going to get rid of the fractions. Now there's only one way to get rid of fractions, and that is to multiply every single term by what we call the LCM. The LCM is the lowest common multiple. So in order to make this work, let me put the 3 over 1. Now you have 3, 2, and 1. The lowest common multiple of all of them is going to be 6. So you're going to multiply the first term, or the first expression, by 6. This one by 6 and this one by 6. All right, how do I do that? Simply, 6 means 6 over 1 if you want to think of it that way so you don't get mixed up. All right, now 3 into 3, so you know how we reduce fractions. 3 into 3, 1, 3 into 6 is 2. 2 into 2 is 1, and 2 into 6 is 3. Now remember the signs. All right, over here 1 into 6 is 6. Nothing changes. The denominators are now gone, which is what we wanted. Now we expand the brackets. So we have 2 times everything here, which is going to give me 4x, 2 times negative 3, minus 6, plus 3, positive 3 now times everything. 3 times 5 is 15. 3 times negative x is negative 3x. And of course over here, 3 times 6 is 18. All right, now let us look for the like terms. 4x, and you have minus 3x. 4x, you take out minus 3x, you're going to get x left, 1x. Negative 6 plus 15 is going to give me a positive 9. And this is equal to 18. So you need x by itself. We're going to carry over the 9. So x is equal to 18 minus 9. Because it was positive, comes over as a minus. X is equal to 9. Now what did I learn from this? Is that the question seemed very complex when it had fractions. The moment I get rid of the fractions, straightforward question. How do I get rid of fractions? Find the LCM of the denominators, or you can call it the LCD, and you multiply each expression by it. All right? Or you think of each of these fractions as a term. You multiply each term by it. Similar concept applied there. And that is the end of it. All right. Let me take out this question since this question was done before, so I can focus on question C. And let me start, if I want to have enough space, I'm going to start question C from right here. So we have 3x minus 2y equal 10, and we have 2x plus 5y equal 13. All right, what is the first step? Label the equation. Equation 1, equation 2. Now, if the equations are lined up like this, it makes your life perfect. Because you're going to be multiplying equation 1 by the coefficient of the x down here, and equation 2 by what is in front of the x up here. That's what coefficient means. You can also work with y. I mean, persons love to work with x. Why not work with y sometimes? All right. So you multiply equation 1 by 2. That's the number in front of the x down here. And equation 2 by 3. That's the number in front of the x up here. So if you multiply all equation 1 by 2, 2 times 3x is going to give you 6x. 2 times negative 2y is going to give you negative 4y. 2 times 10 is going to give you 20. Now multiply equation 2 by 3. 3 times 2x, 6x. 3 times 5, positive 5, positive 15y. 3 times 13, 39. And of course, you subtract, because the signs are the same. 6x minus 6x, that's dead. Negative 4y minus 15. Now, you have to watch the signs carefully. You owe 4, owe 15. Negative 19y. 20 minus 39, negative 19. Not sure? Calculator will never fail you. Divide both sides by negative 19. So y is equal to positive 1. Now, since you have y, you can find x by putting the y value in any equation of your choice. So I'm using equation 1 this time. Y equal 1 in equation 1. So I'm going to have 3x minus 2 times 1 equal to 10. So that becomes 3x minus 2 is equal to 10. All right, let me just take it over the side here. Carry over the 2, it's negative, so it comes over as a positive, right? 3x equal 10 plus 2. So 3x equal 12, and I divide both sides by 3. x equal to 4. So therefore, x equal to 4 and y is equal to 1. And that's the end of it.